In our first example with limits, we're trying to maximize area of a rectangle. It says you're given 24 inches of wire, so that's important, and are asked to form a rectangle whose area is as large as possible, So we're maximizing the area. What should the dimensions of the rectangle have? So one technique is to draw a picture and kind of visualize what we're talking about. So we have a rectangle and we want the area of it. And to find the area of a rectangle is length times width. So we've got area is length times width. Now we also are given that there's 24 inches of wire. So 24 inches of wire tells me the perimeter. So that's how much we have around. So if we think about what these sides are, we've got two widths and two lengths. Two of the widths plus two of the lengths should add up to 24 inches of wire. So this is what we're given. This is information to help us find the largest area, but this is what we want to find the largest of, or we want to maximize. So we have to figure out, well, how are we going to do that? So what we can do is just test different lengths and widths and see what gives us the largest area. But every time we test a length, we need to make sure that the width that goes with it will help add up to 24. So instead of trying random lengths and widths, it'd be best to get one of these variables in terms of the other. So what we're going to do is go over here and solve for one of the variables. I'm going to solve for length. So that means I'm going to subtract 2w to the other side and divide by 2. Again, this is just helping us test values. So I'm not going to have a length and a width. Instead, I'm just going to have widths. So I'm taking this length and substituting it in. And so I've got the area is 12 minus the width times the width. And if I distribute the w, I get 12w minus w squared. So now, if I want to test values and see what happens with the area, I only have to test widths. I don't have to do length and width because I've written length in terms of width. So this is my area equation. And now I'm just going to experiment with different width values. So I'm going to make a table of widths and the area that would go with them. So I'm going to try 5. What if my width is 5? So if I plug in 5 here, I get 12 times 5 minus 5 squared, and I end up getting an area of 35. Now that's pretty big. So if you try different widths and lengths, um, you'll see that the largest we're getting is probably between 5 and 7. Um, so probably 6 is the largest, or is the width that will give us the largest area. So what I'm going to do is go to Desmos and make a table. Instead of plugging each of these guesses in by hand, I'm going to go to Desmos. So let's do that now. All right, so I've gone to Desmos.com and I've gone to the first box, and instead of a and w, I've put in x and y. So I've got y equals 12x minus x squared. And then what I did to get this table was I went to this add item button, and then I went to table, and you click on that, and then there was an x1, and I deleted the little 1 on the x. And then over here there was a y1. I deleted that and put the equation. So I just have x, and then I have 12x minus x squared. And then you can type in whatever you want for these x values, and it'll give you the y value. So we've tried 5. And then what I want to do, since I think the answer is 6, is I'm going to get really close to 6. So now I'm going to try something closer to 6, say 5.5, and I get 35.75. Well, what if I get even closer to 6, maybe 5.9? Okay, that gives me 35.99. 6 gives me 36. What if I go larger than 6? Maybe 6 is not the biggest, so maybe 6.1. Well, it started to go down, so 36 is still my biggest. It started to go down. If I get further away from 6, maybe 6.5, it's still going down. If I go a full step away from 6, say 7, I get back to where I was with the 35. So what we can see is, with the table that we've just made, is that the closer we get to 6 on the x-axis, the higher the areas are getting. And then the further away from 6 we get, the lower the areas are getting. Or we could say, as we get closer to 6 from the left side, the values go towards 36. As we get closer to 6 from the right side, the values also get closer to 36. If we go up the table, it's getting closer to 36. So that means my limit is 36. If I look at the graph, we can see this graphically, that as we get closer to 6, the value gets higher. So we can see that the maximum area, which is this parabola, is at the value of 6. So with our table all filled in from Desmos, we see that the maximum area is at 36, and this is how we would write it. The limit of the area as the width tended towards 6, as the width approached 6, was 36. The limit of A as W approaches 6 is 36. Now that leads us to our definition of a limit. If f becomes arbitrarily close to a unique number L as x approaches c from either side, the limit of f of x as x approaches c is L, and it's written like this. So we're saying the function gets really close to a number. So in that last example, the area was getting really close to 36. So whatever it's getting close to is your limit value. And we're getting close to that number as x does something, as x approaches c from either side. As from the left and the right, x gets closer to c, f is getting really close to this number L, which makes L its limit. So that is what this definition is saying. In example 2, they want us to estimate numerically the limit of that thing. So we've got 3 different ways to evaluate limits. We've got numerically, we've got graphically, and we've got symbolically. So numerically means you're going to make a table of numbers, a table of values. So let's go back to Desmos, and we're going to type in this equation, and we're going to get close to 2. So this x tells me what to get close to. We're going to make the x's close to 2. And the function tells me what my limit's going to be. So I've gone to Desmos.com, and I typed in the function, 3x minus 2, and I went to add an item and added a table, and I changed the first column to just x, not x1. I got rid of the y1 and put the function 3x minus 2. Now I want to figure out how am I going to get close to 2? How am I going to show that the values, what the values are doing as we get close to 2? So what I did was I picked 1.9. 1.9 is pretty close to 2. So I get 3.7. But what if I get closer to 2? Say 1.99. So now I'm even closer. What if I get really close, 1.999? And then we'll look at what happens at 2. And then, so if 1.9 is a step under 2, then what would be my step above 2? So I would go to 2.1 is above it. Closer to 2 from the right side would be 2.01. And then even closer to that would be 2.001. And so we can see 1.9 and 2.1 are really close approximations to 2. But we can get even closer if we move our decimal. So 1.99, 2.01 is really close, and even closer 1.999 and 2.001. So no matter how close we get, if we start at 1.9 and go up, these numbers are tending towards 4. We see these numbers get larger and larger towards 4. If I start above 2 and go down, so if I come from the right side, as I lower my numbers towards 2, these numbers are lowering towards 4. It goes from 4.3 to 4.03, 4.003, so we're getting really close to 4. So the limit is 4, and we can see that numerically. So you're going to put that table in your notes. So that is numerically. But we also can look at the function graphically. So here I'm zoomed out from the last problem. So if I look at this graph, it says as we get close to 2, what is happening to the function? So as we get close to 2, so I'm focused here in the graph, I want to know what are the y values doing on the line. And we see from the left side, so this is the left side of 2, this line is going up towards 4. If I look at the right side of the line, or the right side of the number 2, the line is going down towards 4. And so that tells me that the limit is 4. Because at 2, we're getting really, really close to 4. And actually, in this case, it actually equals 4. So that's numerically. Then we also have symbolically. So I've written all this down. This was the table I got from Desmos. And so my answer, just numerically, is that it's approaching 4. As x approaches 2, the function approached 4. So that is my limit. I then checked it graphically, and I saw that as we got close to 2, the y values went towards 4. And then the third method is to check it symbolically. And symbolically means use algebra or just plug it in. Sometimes you can just plug it in. So if you just plug 2 in, you get 3 times 2 is 6 minus 2, and you get 4. So in all 3 cases, I got the value of 4 3 different ways.